Section 7.4 is on page 451, talks about multivariable linear system. Linear means the power on the variables equal 1, like those. Now here we have three variables, and to graph we're not going to graph those, not in this class. In our next course, Math 8, we'll touch on that a bit, and in third semester calculus, you play with 3 dimensions. So if I want to graph x plus y plus z equal a number, it looks like a plane. One linear equation, 3 variables. If I graph 2 of those, if they happen to be parallel, they don't match, then there's no solution. If they cross, that line right there, let me use a different color, that line right there, okay, thicker, that line right there will stand for infinitely many solutions, and we have to list that. And if I have 3 planes in which they cross 2 each, but there is no specific point that's common to all 3, that's no solution. Again, we're not going to graph those. If they happen to cross like this problem, all of them pass through this line, we get infinite amount of solutions as well. And if they happen to be tilted, in which there's only one point that cross at all of those 3, then that's the point we're looking for. That's one solution. The goal here, it's not as simple as 2 dimensions, 2 by 2. 2 by 2 is very easy to see. We would like to work every problem so that we do the least amount of steps to make it a triangular form. There are 2 triangular forms, we're going to only pick one. So the triangular form here is for you to get a 0 underneath the first entry, and then a 0 right there. And you use what's known as backward substitution, meaning once you figure out z, you substitute z in the second equation, you figure out y, and once you know y and z, you plug that in the first equation and figure out x, and that will be the solution. So the process, the first problem is given to us in triangular form. The homework is on page 459. So if I look at this very first system, this is how it works. I would take the last equation and say, alright, I could solve for z, multiply by 3 halves both sides. And that would mean that z, so again, if these are zeros, I could do that. That would mean that z equal 2 divided 6 3 times, z equal a negative 9. I move up backwards. I'll say on the top equation, we have 2y plus 5. I know that z is a negative 9, and I would solve for z. 2y minus 45 equal a negative 1. 2y would equal 44, and if you divide, y will equal a 22. There it is. And now that I know what y and z are, I go to the first equation and read that as 2x minus 3y, but I know y is 22, plus 4 times z, but I know that z is a negative 9, and that should equal the negative 2, and solve that equation. As long as I get a solution out of those, okay, I'll show you which case that is. Minus, what is that, 12, 102. That means 2x equals, add 102, so that's 100, and that means x is 50. So here, what we got was 50, 22, and negative 9. That satisfy the first equation, the second equation, and the third equation. That's what it means to be a solution. So we are in this case. So every problem I get, I'm going to do steps to make it a triangular. Again, there are two. There's upper triangular or lower triangular. We're going to just stick with one, so you don't need to know the names. My first goal is to make this a 0 and this a 0. How do I do that? So this is called row 1 or equation 1. If I take row 3, you see that right there? If I take row 3, multiply it by -3, and add it to row 1 and put the result in row 1. If I take row 3 and multiply that by a -2, put the result in row 3, multiply this by a -2 and add it to row 2, put the result in row 2. What that will do, that will make that a 0 and that a 0. So this process is a bit tedious as far as calculations. You want to work slowly so that you would avoid mistakes. So on the first equation, probably it's best I line them up so things match better. So here, if I multiply row 3 by a -3, that would be -3, -6y minus 3z, and that's a -12. And if I add that to row 1, -3x plus 3x is a 0. -6y plus y is a -5y. And 2z minus 3z is a -z. And 3 minus 12 is a -9. That takes care of it. That right there is this right here. Now when I get to this equation, so that's this added to this. If I take this equation now and I multiply the same equation by a -2, that would be a -2x minus 4y minus 2z equal a -8. And now if I add this to the second equation and put the result in the second row, -2x plus 2x is 0, -4y minus 3y is -7y, minus 2z minus z is -3z, and -8 minus 3 is a -11. And the first equation, I'm gonna keep it as is. So always 2 steps and you're done, always. The next step, I'm gonna make that a 0. How do I do that? By using those 2 rows. I wouldn't use row 1 because I don't want to change those zeros. So I need to make those 0. Well, if I multiply this row right here, row 2, the new row 2, if I multiply it by 5, and if I multiply row 3 by a 7 and make it a negative, so the signs are opposite, and put that in row 3, pretty much I'm done. Because row 1 I'm not using nor changing. Row 2 I'm using, but I'm not changing. And if I multiply a row 2 by 5, that will be 0, -35y, -15z equal -55. If I multiply row 3 by a 7, that would be 0. That's, I kind of covered it, it's a 5. So if I multiply this by a 7, that becomes -7, that becomes +35y. Multiply this by a -7, that's -7z. Multiply this by a -7, that becomes 63. And if I add those 2 rows, I will get a 0, a 0, a -22z, and 55, is that an 8? Yeah, I think that's an 8. And now I am back to problem number 1. I was able to make this triangle 0, and that's where the triangle comes in. I could say at this stage, if -22z equal 8, that means z is -4 divided by 11. I go up, backward substitution, -7y minus 3 times negative 4 over 11 equal negative 11. I'll clear the fractions. Multiply by 11, negative 77y. Negative 3 times negative 4 is positive 12, and negative 121. And if I subtract 12 from both sides, that's negative 133 if I'm not mistaken. Yep. Divide by negative 77. And I'll get y to be 133 divided by 77. That doesn't reduce. And if I take equation 1 and say that is, I'm just gonna move this a bit to the left. I need a bit more space. So if I take the first equation, that one, that says 3x plus y plus 133 over 77 plus 2 times z, so that's going to be minus 2 times 4 is 8 over 11, and that's going to equal a 3. The LCD is 77, so multiply by 77. 3 times 77, that could be 21, 21, 22, 23. 231x plus 133 minus, multiply by 7, that's 56, and multiply 3 times 77, that's 233. I don't like that 233. I don't know what's going on. Oh, it's toward the side. Okay. And now 233x plus, if I subtract, 8 minus 6 is 2, and 12 minus 5 is 7, equal 233. I'll get 233x equal, if I subtract, that's a 1. 13 minus 7 is 6, and x would be 161 divided by 233. And that would be the solution. The solution will be 161 over 233, 133 over 77. Those numbers are bizarre, but I might have made a mistake. But the process is really what we're after mainly. The chances of making a mistake is very high. I get a solution for that one as well. Now I get to number 6, and it's the same thing. It's no big secret. I'm going to make that a 0 and that a 0. How do I do that? If I take row 1, and again I'm going to lower that, I just remembered. So if I take row 1 and I multiply it by 3, take row 2 and multiply it by 2, make it negative, and put the result in row 2, that will make that a 0. So let me do that. Multiplying row 1 by 3, that makes this 6x plus 3y plus 15z equal a 12. Multiply row 2 by a negative 2, negative 6x plus 4y minus 4z equal a negative 4. If I add those, so in my next set, I'm not going to touch row 1. I might use it, but I'm not going to change it. So if I add those, I'll get a 0 right there. Let me stick with the coloring. I'll get 7y, I'll get 11z, and I'll get an 8. Now, if I multiply a row 1 by a 5 to make that a 0, multiply row 3 by a 2, make that negative, and I think, yeah, put the result in row 3. So if I restart this, I'm going to actually I'll put it up here. Row 1 by a 5, that's 10x plus 5y plus 25z equal a 20. And if I take row 3, multiply it by negative 2, that's a negative 10x plus 16y plus 8z equal a negative, oh, multiplied by negative, that's a negative, that's a positive, yeah, that's right. If I add those, I'll get a 0 right there, I'll get 21y, I'll get 33z, and I'll get an 18. Now, my next step is to make that a 0. How do I do that? If I multiply again, I'm going to use row 2 and row 3 only. If I take row 2, multiply it by 3 negative, and add it to row 3, put the result in row 3, I'm set. I'm pretty much ready for backward substitution. Equation 1 is unused, unchanged. Equation 2 I'm using, but I'm not going to change it, because that's the only row that's going to change. And if I get to the third row, multiply row 2 by a negative 3. That makes it a 0 minus 21y minus 33z equaling a negative 18. If I add those, I'll get 0, 0, 0, and a 0. Well, in this case, I got a true statement. Anytime the variables cancel out completely from one row, either you have no solution or infinite amount of solutions. Here, I got a solution. So, I'm going to still stick exactly with what I did. In this case, I'm going to say let z equal a. What's a? A could be any number that you want. I'm going to go up and say 7. Let me use another color. I'm going to say in the second row 7y plus 11. Instead of z, I'm going to put a. So my answer is going to be in terms of a. Subtract that from both sides. 7y equals 8 minus 11a, and y would be 8 minus 11a divided by 7. Got it. So I got z, I got y. I know it's unpleasant in terms of a, but that's the way it goes. The first equation would be 2x plus y, 8 over 7 minus 11a over 7 plus 5z, that's 5a, equal a 4. Clear the fractions. 14x plus 8 minus 11a plus, if I multiply by 7, that's 35a, multiply by 7, that's 28. So here now I have 14x plus 8 plus 24, a equal 28, move that over, I'll get 14x equal 20 minus 24a, divide by 14, x would be 20 over 14, you could divide by 2, that's 10 over 7, minus 24 divided by 14, that divides by 2, 12a over 7, there's my solution. So the solution here with a variable indicate that you have an infinite amount of solutions. You could put that one shot if you want. And this is 10 minus 12a divided by 7. That would be my solution. So it's same process. That makes it hopefully easier to follow. One more to go. I'm looking at this, and here I notice there's only 2 equations. Well, okay, let's make that a 0. So I'm going to multiply the top row. I'm going to multiply row 2. I made it again. Same mistake. I'm going to take row 2, multiply row 2 by a negative 2, add it to row 1, put the result in row 1. So here, I'm looking at, if I multiply row 2 by a negative 2, doesn't that become negative 6x? Okay, that's not working. Let me scroll down a bit. Doesn't that become negative 6x plus 4y minus 2z equal negative 14? If I add those, so 6x row 2. The first row I always use, but I don't change. If I add those two, negative 6 plus 6x is 0, negative 4y plus 4y is 0, 2z minus 2z is 0, and 5 minus 14 is a negative 9. This says 0 times z equal negative 9, but we know that 0 times any number is 0. Therefore, here we say there's no solution. those don't ever interact. So when you work these problems out, make sure that you're working slowly, otherwise the answer could be way off. Most of the credit is going to be given toward the steps if you're trying to make those zeros like I did. And there's the homework, and that concludes this section.